This is Physical Science 2, Chapter 21, Part 3 on Earth's Changing Surface. In this portion of the video lecture, we will be discussing groundwater. In order to discuss groundwater, we need to review a little bit of the water cycle. Remember, the majority of Earth's water supply for the whole planet, about 97% of Earth's water supply is in the form of salt water for the oceans. So that means around a little less than 1% of Earth's water supply is what we consider usable. Usable to at least the human race would be water in the form of lakes, rivers, and streams, and groundwater. The majority of our fresh water supply is locked up in glaciers and ice caps. So we only consider water that is usable in the form of rivers, lakes, and streams or groundwater. Luckily for us, the Earth is a great recycler of many things. Water is one of those. Freshwater supplies are constantly replenished through the water cycle. And so the sun has that thermal energy to power both evaporation and what's called transpiration. Transpiration is how plants evaporate water through their leaves, and that does contribute to the water cycle, albeit a smaller portion than evaporation from large standing bodies of water. But the sun is the driver of the water cycle. So how do we get groundwater? We get groundwater through the water cycle by what's called infiltration. So in some cases, when there is extra water, that water can either evaporate and then, of course, form to clouds and then condensate and fall back as precipitation. Or that water can run off into some type of storage on the surface in rivers, lakes, streams, or oceans, or that water can go underground and become stored there. When we talk about groundwater, there is certain zones that we can figure out where the groundwater is. So these zones they can be at different depths inside the soil. It depends on the topography of the area. But the unsaturated zone, this is the region that's very close to the surface. So this is where water can infiltrate freely. So this is where the soil, of course, is taking the water down by gravity to lower levels. Eventually, the further down you go, you will hit what we call the saturated zone. So this is the region below the surface where there's water all in the pore space. So there's no more space. So that's where the infiltrated water will sit in storage. So the water table is what we call that boundary that separates the saturated and unsaturated zones. So in order to get groundwater, you have to be below the water table. So the water table will be at the very lowest point where any outstanding body of water, a river or a lake is at that same level. Under the soil and other areas, that's where the water table will be. The Earth has kind of little storage units for groundwater. We call them aquifers. An aquifer is a rock unit that can transmit water through its pore space. An aquifer is and does act a little bit like a filter. So the aquifer can take out some of the impurities of the water as it infiltrates through the surface. And then it is stored in the aquifer, so it sits on top of solid rock, so that water can't further infiltrate below the aquifer. So if water is pumped out faster than can naturally be replenished, that aquifer could go dry and stay that way. So for people that get their water from a well source, Generally speaking, those wells are below the water table and they're fed by an aquifer. And so if there's more water pumped out in a season that can be replenished by spring rains, that aquifer could go dry. We talked about porosity when we talked about sediments in our last chapter with earth materials. Permeability is another a measure of how well a fluid can pass through a material. So if a material is very permeable, it will have lots of pore space. So the more pore space an aquifer has, the more permeable it is, the more water can filter through that aquifer. So where do we get and how do we get our groundwater? We have to dig wells below the water table. So much like surface water, groundwater also flows downhill. And so you have to get far enough below the water table in order to keep a constant supply of water. Otherwise, at certain times of the seasons, the water table can change. Generally in the springtime, when we have lots of heavy rains and snowmelt, the water table is very high. During the middle of August, when it's very dry, we can have the water table being a little bit lower. Sometimes we have natural types of wells that can form. These are called artesian wells. Artesian wells form under pressure where the water is actually forced up to the surface without having to pump it. Artesian wells generally occur on a slope on a really saturated area. So the water table would be very close to the surface, and so just the sheer pressure can force the water up and out of an artesian well. The reason why we need to be concerned about groundwater, even though we can't see it, is that pollutants, either natural pollutants or man-made pollutants that are spilled or dumped on the ground, if they enter the groundwater through infiltration, that aquifer and that groundwater takes a long time to recharge and filter those pollutants naturally through the soil. So the earth itself will take care of some of the impurities. But if groundwater becomes polluted, it will more than likely stay that way unless that groundwater is pumped out and treated. So we do need to be careful about things that we put on the surface, things like pesticides and insecticides and other different chemicals that we use for a lot of everyday things in our lives. Because when those things get into groundwater, we have a very difficult time naturally filtering those materials out. This has been Physical Science 2, Chapter 21, Part 3 on Earth's Changing Surface.